13 billion years ago, the stars manufacture many of the heavy elements that make up your car today. Fusion takes place inside the core of the star. When iron is created in the core, the star collapses, dies, and explodes. This is called supernova, and all the elements that it had created are then dispersed out into space. And today, iron is all around us, in the form of cars, trains, and buildings. However, iron, especially mild steel, reacts readily with oxygen to form iron oxide. Rust is one form of iron oxide, and preventing it is a constant struggle in the industries. The consequences of corrosion is terrifying. It is not only poses life and environmental risks, but also affects the economy. A corrosion inhibitor is a substance that can reduce corrosion effectively. Commercial inhibitors that are used today are mostly not sustainable, chemical-based, and are toxic to human health and the environment. Therefore, there is an emerging demand on green corrosion inhibitor. As one of the major global producer of palm oil, Malaysia produces 19 million tons of palm oil annually. But at the same time, we also produces a massive amount of empty fruit bunch waste. The abundance of EFB as a lignocellulosic biomass provides unlimited and inexpensive source for various applications. So, how to convert EFB waste into a corrosion inhibitor? EFB exists in the bulky form of fiber. Initially, the EFB is dried and cut to smaller size of fiber, around 1 centimeter length. Then, the fiber is ground to further reduce the size to 300 micrometer. This powder can already be used as a corrosion inhibitor, but as of other natural fiber, the inhibition effect is temporary, and the EFB degrades over time. To tackle this problem, the EFB is chemically treated with acid to isolate the active compounds that is responsible for inhibition. The treated powder is able to reduce 88% of mild steel corrosion. Hydrogen gas is produced in acid corrosion of steel. Adding EFB inhibitor significantly reduces the gas bubbles formation, indicating reduction of corrosion. This proves that EFB waste is able to make the 13 billion years old stardust last longer than it should be. If this technology is successfully applied in the industry, we are one step forward to make industrialization and palm oil production more sustainable. EFB corrosion inhibitor is capable of assisting us in achieving SDG 9 and 12. So, do you think this technology is worth to invest?